Good afternoon and welcome to Automated Container Security for DevOps or DevSecOps. In this 20 minutes, we want to take a look at how we can integrate security in your daily operations so that security can be fully automated, it's not sitting in the way, and it's being part of your daily operations and your automation capabilities. My name is Chris van den Abbeele, or at home, which is Brussels, Europe, Belgium. They call me Chris van den Abbeele, which is totally impossible over here, I know. I'm a cloud security architect, and I'm having a great time with Trend Micro. Okay, so Trend Micro, I'm not going to waste too much time on this. We are like 6,000 employees, over 50 countries. More important, we are in security business for over 30 years, which is important. If you are looking for a security partner, you want someone who's been seasoned, who's been, around the block for a while, who knows a lot about security. And actually, some of them say we have the best threat intelligence in the world. Some of them is Frost & Sullivan, who did a survey. And they figured out that the survey they did in 2018, and they found out that of all the 0 days that were found in 2017, 66% was found by Trend Micro. Trend Micro, with our zero-day initiative in our tipping point division, we have long-term be number one, and then we acquired tipping point. So we have number one and number two on threat intelligence coming together, and that's why we are like overwhelming that space there. So also the product I will talk about, I'm not going to focus too much on the product. I want to focus more on the capabilities and what you have to keep in mind when you look for securing your container environment. But the product I will talk about is Common Criteria Certified. Who knows what common criteria is? A few people, typically military, finance. See a few nods. Yeah, okay. So if you know what it is, you know it is important, and you know that a product which is certified for common criteria, it stands for quality, it stands for using best security practices even inside the product that you build to provide protection. So this week at DockerCon, we are going to focus on containers, but be realistic. In the real world, not everyone has only containers. Most of the enterprises, they have virtual machines, physical machines, machines in the cloud. They have a whole landscape that they need to protect. And now they have this new thing of containers coming around the block, and they're thinking like, okay, am I going to need yet another security tool to provide security? And I have those security controls as here on the right bottom of the screen. I have, do I need a separate agent for my anti-malware? Do I need a separate agent to provide intrusion prevention? If I need to set up firewalling, integrity monitoring, URL filtering, application control, all of those, it becomes a pretty complicated matrix. Well, the good news is you can protect this entire landscape with all of those 7 security controls, including the containers on the landscape. You can do that with one single application. So let's spend a few minutes just on virtual machines before we go to containers. How do you protect compute instances? This is a screenshot of the console of Deep Security, and you see a lot of virtual machines here. For example, this is a Solaris machine you see here. You see SUSE Linux, Red Hat Linux, Microsoft Windows, and so on. So you see the whole scale of operating systems here. This one is a machine that runs a Docker engine. So it could be like a worker node of a Kubernetes cluster, or it could be a swarm node, or whatever, a machine that runs the Docker engine. So on that one, we automatically give you the icon of containers, so you know that that one is running containers. Here we see like 2 SAP SAP systems. SAP NetWeaver Gateway and SAP GUI system here. And then at the left of the screen, we see what we call connectors. Those connectors connect to the control plane of the target architecture, which could be VMware vCenter. We're talking about virtual machines or cloud machines. So VMware vCenter could be AWS, could be Azure, could be the Google Cloud. And those connectors are very important because they give us like a real-time view of what happens in that target area. So, for example, if someone creates a new virtual machine, in this case in Google Cloud, and I have an Ansible a script that I run here. So I just created 4 virtual machines, 2 Windows ones, 2 Linux ones, 2 database servers and 2 web servers. So I have a little bit of a mix here. They were created through an automation, through Ansible. They show up in my Google Cloud, which I just took as an example here. And in the same automation, in the same script, we are now deploying an agent on the platform so that we can take control for security on that machine. You see here the virtual machines, they are being created in our dashboard, all automated without touching anything. It's all integrated stuff. Here you see the machines, they get their policies assigned, they get managed. The security agent is taking control of the security aspects of the machine. And then if we go a little bit more in detail, you see here that we do anti-malware, URL filtering, firewalling, IPS, integrity monitoring, log inspection, and application control. And all of that with one single agent on those platforms. And so far, we didn't have to do anything on the GUI. Everything was API-driven and fully integrated from the CI/CD pipeline. Applying security controls, okay, applying antivirus, that's pretty simple. You flip it on and you set some exclusions, and basically that's it. But intrusion prevention, IPS, that's a bit of another story. You need to figure out which vulnerabilities do I want to shield, to prevent exploitation from. So you need to basically run a vulnerability scan to find out what vulnerabilities you have on those platforms, and then you apply the matching IPS rules. In this case, we're lucky because there is a recommendation scan, as we call it, which is a kind of a vulnerability scan, which is built in the product, and it can be kicked off automatically and tell you which vulnerabilities are found on the platform, and it can automatically virtually patch them, as we call it. So it can apply IPS rules so they cannot be exploited. Here is a screenshot of the SAP NetWeaver Gateway system that we mentioned earlier. And on that one, we found 991 vulnerabilities, which is a lot, but in real life, this is a critical system, so people don't go and just take it offline to do patching every month. It's not really possible. And so not many, certain enterprises, they think, okay, if it isn't broken, then don't fix it. So they let it run, and they finally see they have a lot of vulnerabilities, and the attack surface has grown over time. So with IPS, those vulnerabilities are automatically shielded, and so they cannot be exploited. Okay, that was a little bit on virtual machines and cloud compute. Now let's focus on containers. Containers on premise or in the cloud, or doesn't matter. So this is a typical build pipeline. I guess we don't need to spend too much time on this. A coder writes code, push it to a repository, GitHub, for example. Then we have a builder connected, Jenkins or GitLab. It sees the new version of the code. It starts building a container image, which is then pushed to a container registry. And then we have the orchestrator that can actually run container instances for us. So this is a typically fully automated pipeline. Now, when it comes to security, let's take a look at where are the risks on containers. And so during build already, there is a huge risk, because what do we do? How do we build containers? It's all built out of layers with kind of Lego blocks that we put one upon another. And so where do we get those modules and libraries? Where do we get them from? We get them from public repositories, right? But how do we know they are vetted? They are, up to the latest security level. They are the latest product versions, and they don't have vulnerabilities. How do we know that? Basically, we don't. So that's our first thing when it comes to security that we need to consider. But also at runtime, containers, it is software. For example, if it is a small web server, if it runs in a container or on a virtual machine, it doesn't really matter. Okay, I give you that. A container has some kind of a shielding already around the application. But other than that, the web server is still vulnerable, can be exploited through cross-site scripting, SQL injection, or, for example, recently we saw the Apache Struts vulnerabilities. So again, vulnerabilities are kind of linked to software. Any software has vulnerabilities that can be exploited. But also below the container, you have the orchestrator. Orchestrators, again, it's software, so it may have vulnerabilities, and you have to protect those as well. And even one layer lower, you have the operating system, the OS, the Linux that runs your Kubernetes worker node, for example. So those ones also have vulnerabilities, and we need to look at protecting them. So let's go in a little example here. In the next, I have pre-recorded the demo just to save time. So I will build, this is the DevOps, the pipeline. So this is my GitLab overview. You see here, all of those are different pipelines, and every pipeline has 3 stages. The first stage is where I build my container. Second stage is where we go to testing it. You want to test something before you put it in production. So that's stage number 3. We do a deployment of the container. I have taken this demo application, which you can find on the internet, DVWA. It is I'm not going to say that swear word, a vulnerable web application. And you can use it to test your security posture against. So first thing, I want to get rid of this swear word. And second thing, I want to replace that logo by my company logo. So what do? I go to the Docker file. I open my beloved VI. And there we go. You see here in blue, I have 2 lines which are remarked out. So what I'm going to do is I'm going to use the SED, the set, to replace that, find that swear word and replace it by something else. And I'm going to do that in the index.php file. And next thing, I am going to do a wget for a logo file, my company logo, and I'm going to use that in my, my container. So there we go. That is done. So next step, I push it to Git repository. There we go. And then you can see that the builder automatically sees there is a new version out there. It starts building. It is downloading all the layers. It's building a container image. I mean, this is no rocket science. We've done this multiple times. There we go. Takes a moment. And thanks to supercomputers or maybe the magic of video, it goes a little faster than in reality. Okay, job done. So we have a container image. Step number 2 is now testing it, making sure it is up to our security requirements. So you see here that our pipeline automatically calls our security scanner, and that one triggers a scan to scan that container image. So before it goes into production, we want to scan every container image. We are scanning for different things. We scan for vulnerabilities, which like everybody does. We scan for malware also, and we also scan for forgotten private keys or access tokens, which never happens, right? You never have a private key that you have lost and which is in your container. So we scan for that as well. So there we go. We have found one malware, and this means that we failed the pipeline. So if we take a closer look at what our scanner found, we found the logo file contained malware, and then we have all those vulnerabilities here that we find. If you click on one, we lead you to a solution, which is in this case the Ubuntu website that gives you how to fix it. We have a nice dashboard showing you are all my systems covered, which one needs attention, where are my security risks. But more important than the GUI and the dashboard is the API. Everything is API driven. Next step, I want to launch a container. So we have this admission control, which is a standard capability of Kubernetes. And here you see if a container has not been scanned by our system, you can say you're not allowed to run it. Kubernetes will not run it. So that was pre-runtime. Now let's go to runtime protection. You have to protect, as I said, the operating system, you have to protect the orchestrator, and you have to protect your running container. So which is like all different things. Now we have come up with an easy way to do that. You just deploy a privileged security container, which can do all of the scanning of those three target areas. It deploys as a Helm chart, and it protects, as I said, containers, orchestrator, and the hosts it runs on. Pretty simple, pretty easy, deploying a container. We've done that before we know how it works. This is how we do it, deploying the Helm chart. You have all my worker nodes, they get that privileged container deployed, and then they show up in my dashboard, all automated, all integrated in the CI/CD pipeline. And then the last step, sometimes you are running your containers on a platform that is not under your control. It's AWS Fargate, for example. It is as a service platform. So the way to protect your containers there is using a RASP technology, where you actually create or integrate a micro agent into your container image. This is an example. This is not really a container, so the technology is not limited to containers. It's a Python script here, so we just import that layer there, and when someone tries to do a SQL injection, the attack is blocked. Okay, containers is all about focusing on developers, helping developers. So we have a few resources for you if you are a developer. We have an automation center with all the API calls, with sample code and so on. We have a pretty extensive Git repository where you can download code snippets and things. If you want to have more details, and I see that I'm running out of time, I can see you in the hallway afterwards, or you can come to our booth. We can do a more detailed demonstration if you want to. We can do that over Zoom or WebEx or anything. Here, so to summarize, containers are important, container security is important, but be realistic. In the real world, there's a whole landscape that needs protection. There are virtual machines, there are cloud machines, there are physical servers. And when we say security, we mean security like all of those security controls. And finally, tools are important. Tools and capabilities. You can have a checklist and say this vendor does this and checks for that and checks for this and everything. Threat intelligence is, in my book, the most important thing. If you have a cool, great tool, but you don't have good threat intelligence behind it, then your tool is basically worthless. And with that, I'm going to clear the floor for the next speaker. My time is up. So questions, I'm sorry. Yeah, see us at the booth. We are downstairs. Thank you.